A reading of Richard Rhodes' The Making of the Atomic Bomb, February 23, 2011, read by Craig Wyatt.
This is from chapter 18, titled Trinity. This book is the story of 200 years of history and science, leading up to the moment about which I'm about to read. It all culminates in a stretch of desert in central New Mexico called the Jornada del Muerto, the Plain of Death, on July 16, 1945. The last decisive in action was Horning's, Donald Horning, a young Harvard physicist who was also the last one off the tower on which the plutonium bomb had been mounted. Horning later wrote, "Now the sequence of events was all controlled by the automatic timer, except that I had the knife switch, which would stop the test at any moment up until the actual firing. I don't think I've ever been as keyed up as I was during those final seconds. I kept telling myself, the least flicker of that needle and you have to act. It kept on coming down to zero. I kept saying, your reaction time is about half a second and you can't relax for even a fraction of a second. My eyes were glued on the dial and my hand was on the switch. I could hear the timer counting. 3, 2, 1. The needle fell to zero. Time, 05:29 hours, 45 seconds. The firing circuit closed. The X unit discharged. The detonators at 32 detonation points simultaneously fired. They ignited the outer lens shells of composition B. The detonation waves separately bulged, encountered inclusions of barytol, slowed, curved, turned inside out, merged to a common inward driving sphere. The spherical detonation wave crossed into the second shell of solid fast composition B and accelerated, hit the wall of dense uranium tamper and became a shock wave and squeezed, liquefied, moving through, hit the nickel plating of the plutonium core and squeezed, the small sphere shrinking, collapsing into itself, becoming an eyeball. The shock wave reached the tiny initiator at the center and swirling through its design irregularities to mix its beryllium and polonium alphas, kicking neutrons free from scant atoms of beryllium. 1, 2, 7, 9, hardly more neutrons drilling into the surrounding plutonium to start the chain reaction. Then fission, multiplying its prodigious energy release through 80 generations in millionths of a second, tens of millions of degrees, millions of pounds of pressure. Before the radiation leaked away, conditions within the eyeball briefly resembled the state of the universe moments after its first primordial explosion. Then expansion, radiation leaking away. The radiant energy loosed by the chain reaction is hot enough to take the form of soft X-rays. These leave the physical bomb and its physical casing first, at the speed of light, far in front of any mere explosion. Cool air is opaque to X-rays and absorbs them. Heating, the very hot air, Hans Bethe writes, is thereafter surrounded by a cooler envelope, and only this envelope, hot enough at that, is visible to observers at a distance. The central sphere of air, heated by the X-rays it absorbs, re-emits lower energy X-rays, which are absorbed in turn at its boundaries and re-emitted beyond. By this process of downhill leapfrogging, which is known as radiation transport, the hot sphere begins to cool itself. When it has cooled to 500,000 degrees in about 1/10,000th of a second, A shock wave forms that moves out faster than radiation transport can keep up. The shock therefore separates from the very hot, nearly isothermal, that is, uniformly heated, sphere at the center, Bethe writes. Simple hydrodynamics describes the shock front like a wave in water, like a sonic boom in air. It moves on, leaving behind the isothermal sphere, confined within its shell of opacity, isolated from the outside world, growing only slowly by radiation transport on this millisecond scale of events. What the world sees is the shock front, and it cools into visibility. The first flash, milliseconds long, of a nuclear weapon's double flash of light. The flash is too closely spaced to distinguish with the eye. Further cooling renders the front transparent. The world, if it still has eyes to see, looks through the shock wave into the hotter interior of the fireball. And because higher temperatures are now revealed, Bethe continues, the total radiation increases toward a second maximum. The second, longer flash. The isothermal sphere at the center of the expanding fireball continues opaque and invisible, but it also continues to give up its energy to the air beyond the boundaries by radiation transport. That is, as the shock wave cools, the air behind it heats. The cooling wave moves in reverse of the shock wave, eating into the isothermal sphere. Instead of one simple thing, the fireball is thus several things at once. An isothermal sphere invisible to the world, a cooling wave moving inward toward that sphere, eating away its radiation. A shock front propagating into undisturbed air that has not yet heard the news. Between each of those parts lie further intervening regions of buffering air. Eventually, the cooling wave eats the isothermal sphere completely away, and the entire fireball becomes transparent to its own radiation. Now it cools more slowly. Below about 9,000 degrees Fahrenheit, it can cool no more. Then, continues Bethe, any further cooling can only be achieved by the rise of the fireball due to its buoyancy, and the turbulent mixing associated with the rise. This is a slow process, taking tens of seconds. The high-speed cameras at W10,000 on the Trinity plane recorded the later stages of the fireball's development. One witness reports tracking its huge swelling from the eyeball it had been. The expansion of the ball of fire before striking the ground was almost symmetric, except for the extra brightness and retardation of a part of the sphere near the horizon, a number of blisters and several spikes that thus radiate ahead of the ball below the equator. Contact with the ground was made at 65 thousandths of a second. Thereafter, the ball became rapidly smoother. Shortly after the spikes struck the ground, about 2 milliseconds, there appeared on the ground ahead of the shock wave a wide skirt of lumpy matter. At about 32 milliseconds, when the fireball had expanded to 945 feet in diameter, there appeared immediately behind the shock wave a dark front of absorbing matter, which traveled slowly out until it became invisible at 85 thousandths of a second. The fireball was now 2,500 feet across. The shock wave itself became invisible at about 10 thousandths of a second. The ball of fire grew even more slowly to a diameter of about 2,000 feet until the dust cloud blowing out of the skirt almost enveloped it. The top of the ball started to rise again at 2 seconds. At 3.5 seconds, a maximum horizontal diameter, or neck, appeared 1/3 of the way up the skirt, and the portion of this skirt above the neck formed the vortex ring. The neck narrowed, and the ring and fast-growing pile of matter above it rose as a new cloud of smoke, carrying a convection stem of dust behind it. The stem appeared twisted like a left-handed screw.